we are on the page 21, section 2.1. We started to talk about calculus. Okay, started from the concept, something called limits and derivatives. So for section 2.1 and 2.2, they are very dry for you. But the calculus starts from here, from the concept. Then we just have to go through it. But once we start to use it, it will be fine. So the concept is very abstract. Those were developed by math people, but we start from here, and for this class, all we need just to apply it. So, but we have to show you how things started. Okay, so these two sections are very dry for you. Just bear with it, it will be fine. So that's started from something called limits. Okay, calculus started from here, and limits are mainly is talking about the limitation. Limits is a limitation, right? Limitation of y values. So we talk about algebra. It's all about functions from a to b, from x to y, right? So limits is talking about from x to y, and for all your x's, what's your y's limitation? So the limitation, it looks like this. Let's just use some example first, right? So if I have, say, 2x, y equals, say, y equals 2x, y equals 2x. We are talking about this function, right? F of x equals 2x. Then, what kind of limitation we are talking about within the x value from your x to y, certain x value, say x is your years, within next, say 10 years, what's your, say production limitation, revenue limitations, right? That would be your y value. So we started from limits concept and how to use calculus to handle the situation. So we start to learn the basic concept. So we use the limit, then we use this symbol, x approach to 3. What does that mean, right? That's your f of x, right? Y. So that's a find the value. So what are we talking about? So it means what? When you approach to third year, and what happens if the function is like this? Your profit is this way, right? So we just do it mathematically first. So this one is what? X approach to 3. So because it's the line, let's just start from the things you know, and with the line. How do you graph the line? T-table, right? X, for this function, x is 1, y is what? 2, right? And x is 2, y is 4, x is 3, y is what? 6, right? We used to do that. And that would be the line for the function y equals what? Y equals 3x. That up to 2x we are talking about, right? Then when we approach to 3, So this one, x approach to 3, it means, say, the third year, right? And so that's your x. When x approach to 3, this is a 3. Then what's your limit of the y? That was the concept of limits. Okay? So let's take a look how we can decide the limit. That means x approach to 3. X approach to 3 can be either approached from left or approached from right, right? So you can, x approach to 3 means what? X can come either way. So we are going to approach from the left. See what will happen? What do we mean by approached from left? Right? That's your y equals to x. Approach from left means those points getting closer to the 3. So it can be 2.9, right? 2.99, 2.999, things like this. When we plug in 2.9, right? So what's your 2x? Will be 5.8, right? Double, right? Then you keep going. This will be 5.998, right? If you're getting closer, 9999, that will be what? 5.9998. Is that right? Okay, so we are talking about from the left. What happens if it's from right? So if you are from the right side of 3, that means x is going this way, right? So what kind of number would be that? Right? So it can be what? 3.1, 3.01, right? Getting closer to that side, to the 3. Can be 001, and so on, right? So if you double it for the 2x function, that would be 6.2, 6.02, 6.002, right? Getting closer, right? So what are we doing is we just do it by observation. About the behavior of the limits. That's what we are doing. Okay? So, what do you think? When it's approached to, x is approached to 3, what's your y? What's your y's limitation? The y would be bounded by what? Okay, so you can see that's our y, right? This one getting 5.9998, 5.9998, then this one will be 6.002, 6.002, right? So for these two numbers, a little bit very close for y. This getting bigger, this getting smaller and smaller. So your y is bounded by what? Y will be approach to 6, right? So your y is coming from this side, it's going down, approach to there, and from this side, it's going up, approach to there. So it's bounded by what? 6. So limit of 2x the answer is 6. We are learning the limits concept by observation right now, right? But later on, we just do it very simply. What do? If you plug in 3 times 2, you get 6. Okay? Under certain conditions, we can just directly plug in and to find the answer for the limit. Finding it is not that bad, but the conditions are complicated. Okay? But right now, we can just do that. So let's take a look at another one. If I have limit x my approach to 3, but my equation 2x plus 4, right? We'll try to find the answer. So this means what? Y equals 2x plus 4. And this one is a condition we can use to plug in directly. What do you think? 3 times 2, 6 plus 4, 10, right? So the answer is 10. But right now, let's just do the observation first and see we actually can get that the y will be bounded by this situation, right? So what do? We say you observe it from the left, right? And you also observe it and from the right, right? So we do our t-table, x, y equals 2x plus 4. So we say approach to 3. 3 can be from left-hand side and from right-hand side. So we can use 2.9, 2.99, 2.999, right? Then you plug in, so you continue, you plug in all the value, then this one will be 9.998, right? So if we do observe it from the right-hand side, so what kind of number we should use? Approach to 3 from right-hand side is bigger than 3, right? Like 3.1, but getting closer to the 3, so smaller, and but more close to 3. So you plug in, you will have certain number just by plugging, so right? Things like that. Then next number will be what? 9998. Oh, no, not necessary. You have to plug in, okay? To find the number, to find the exact number, okay? But you will see these two numbers, your y start to approach to what? 10. That's why your limit is 10 for this function. And you can see if we plug in 3 directly, then we will get 10. Okay, so this is by observation. Now we are going to define it and describe it in a formal way. Okay, so the notation we use is what? Limit, right? So x approach to c. C is a constant, just like your 3 earlier, right? Then the function f of x means what? That's your y, right? Early on we have what? Y equals 2x. So equals what? L. And L means what? It's the number y is bounded by. Okay? So what it's saying is the limit of f of x, which is what? Which is your y, right? Talk about limitation means limits, means the y value is bounded by certain number. So limit, we are talking about limit of f of x is L, right? If we write it this way, we are talking about limit of the f of x is L as what? When x approach to a number c, right? So this one means x is approach to c, right? So you have two situations. You have to check from both sides. From what? Left. From the left will be what? Like we approach to c, we use c minus, means little bit less than c. Approach to left hand side, and from what? Right hand side will be, we use this notation. Like previous one, approach to what? 3. So we use 3 minus 3 plus this way. So if we write it this way, limit of what? F of x equals L. If we write it, say c little minus superscript negative means minus from the left hand side. That means what? Your limitation is f. Your limitation is L as what? As x approach from left hand side, right? So that's the notation we are learning. So first we learn the concepts by observation. Now we are learning the symbols, how to write the limitation. It's a relatively dry for you, but it's manageable. So if we use this notation, C plus there, it means what? Okay, from the right hand side, when I approach to the number, right? And if it's 3, that means after third year, a little bit past, what's my limitation, my profit as y, right? So this one will be x approach to what? On the right hand side. That's, this one means what? From the left, right? Then this one is from the right. So we are learning the symbols first. Okay? So rules of limitation. How do we actually calculate? Okay? We say is this limit y, okay, y value limit x of f of x when x approach to c equals f of c. What does that f of c means? Just like earlier, f of x equals 2x, right? So when c is 3, right? You plug in. That means f of 3, then you get a value. So we do what? By plug in, right? To here, then formally we say what? By direct substitution. Okay, so we say the limit exists when this value, right, y, is bounded by one value. If you approach to both left and right side, if you get the same value and bounded by, then we say, ooh, the y value is limited. So from both sides will be bounded by just one value. You have to just have one value for the y. Y is limited by one value. If two values, that would not be called limited by, right? So if it's limited by just one value, then we say it has the limit. Okay? So let's see some more example. Look below, say, okay, this one is complicated. Okay, so it's very little bit confusing, but that's okay. And we say find the limit of this one. 1 plus x and 1x power, right? When x approach to 0. You say, what the hell, we need to know that. That's how things started, how the world started. And that's how we use all the calculus, and we go to the moon, and we can invent the calculator. Not the calculator, the cell phone, right? All because started from things like this. You will find out why. Then the limit x will approach to 0. Why we use 0? Because 1 over 0, we cannot do that. We say 0 cannot be what? The denominator. So you can only approach it, but you cannot be that way. Okay? So let's find out why we are talking about this. Let's just do some math first. Okay? So we do what? From the left of 0, right? Because the approach to 0 can be from left hand side and from the right hand side. Because you cannot use 0 to plug in. Before we can just say plug in, find the value. But this one, you cannot plug in because the denominator cannot be 0. So we want to find the limit, we cannot plug in. So what can we do? We can only do by the table. That's why we say finding a limit by a table, right? So your y is what? That guy. Then we also do it from right hand side. See what will happen, okay? So from left hand side of 0 means what? Negative number, and getting closer to the 0. So I start from, okay, a little bit less, then and a little bit more, closer to the 0. Is that right? We can do that. Okay? Because the denominator is not 0, we can plug in the calculator and to find the value. So you do 1 plus negative 0.1, then to the power 1 over the number. Okay? You can try it on the calculator so you can practice that. So you will get this value, you will get this value, and, right? So you can follow the class, follow along, get a blank paper and write it down yourself. Then you can register better. Or you can get printed out the answer key to follow along as well. But it's better, I would think, for you to write it yourself so you kind of connect better. Okay, so for this side, if you have this number, it's getting closer to 0 from the right hand side, approach to 0. So it's like 0.1, 0.001, right? Getting closer and closer. Then you plug in the calculator, then you will find out it's such value. Okay, of course it has more decimals, right? So just by observing these two, you realize what's your limitation of the y. What do you think? Okay, so And we cannot plug in 0, so we use this approach by the table. Then you will find out your limit will be what? Will be close to this one. Okay? So, take a look at this number. What do you think this number is? We did earlier. That's your natural log E. Remember? 2.718 something? That's by the German guy called Euler. So he, not invented, he discovered this number by doing what? Doing the limitation for this. Okay? So the reason you cannot direct plug in, finding the limitation by this concept, because you cannot plug in the denominator as a 0. If you can plug in directly, most likely you should be able to do it directly, follow the rules. Okay? Let's see. We are still on page 21 on the bottom, and we are going to practice by direct substitution by plugging in to find the limit. So look at your example. Okay, do you think you can direct plug in, use the rule? If you plug in, what will happen? Right? You plug in 4, limit it's gone because you already find the answer. So by doing that, you get a 2. The answer is 2. Okay, for this graph, remember, you have what? Square root property means a sideways parabola. Then when x is 4, your y value is 2. So it doesn't matter you approach to the right-hand side or left-hand side, you get a 1 value. Then second one, limit is this, x squared x plus 3 equals, you plug in directly, will be 6 squared, 6 plus 3, then what do we have? Right? Will be 36, 9, that would be 4. That's how we direct plug in to find the value. Okay? Okay, let's look the page 22. So let's see. If I have a limit x to 0, okay, I have x. Do you think I can direct plug in? Of course, without any restriction. So that would be 0. And if I have limit x over x, x to the 0, right? Can we plug in? Because the denominator cannot be 0, so you cannot plug in, right? So we cannot plug in. Then what can we do? So, but look at that. Can we cross cancel the x? So we do this way. All right. So you can do it limit and approach to 0, right? So if you cancel out, then become limit x approach to 0 is 1. So the answer is 1. Right? If you look at the graph, you will see y equals to x. Y, oh no, it's not x, this one. We are talking about this one, right? So limit 1 means y is 1. So that's your y. Y is 1. So when x approach to 0, from left-hand side or right-hand side, the y is bounded by what? How far you can go up and down for y, right? Y doesn't go up and down, just close to 1. So you are limited by 1. And if you have this one, limit x approach to 0, x squared over x. Can we plug in? We cannot, right? Because that will make denominator 0. So what do? So we simplify first. So we do it this way, right? So if you cancel out, that's your x, then that will be limit x approach to 0 to the x, right? Can we plug in now? Yes, you plug in with 0. So if you look at this graph, that will look like this. That's your x, right? So when x approaches from right-hand side and left-hand side, what's your y value bounded by? How far it can go up and down? Just bounded by a value, right? That's the value. Okay, so what did we just do? If we cannot plug in directly, another way to resolve it would be what? We simplify first. So if we simplify both, then you see we can plug in. Then we do that. That's how we do. Okay? So we do the simplifying first. Then look at the example 3. So if I have denominator x minus 1 and this, can I plug in directly? Okay, we can't. So what do? We simplify first, right? So we write this one and do your math, factoring. So x squared is what? A squared minus b squared equals a plus b, a minus b, right? So this is x minus 1. So you cancel out this. Then what do we have? Limit x approach to 0, x plus 1. Can we plug in directly? Yes, we can do that. Oops, it's not 0, it's 1. Right? So what do we have? So plug in directly, that would be 2. Are we good? So we are finding the limits. So let's see. Special cases always something is out of the ordinary. Okay, so sometimes a limit doesn't exist. That's observed, right? So let's see. If I give you a function equals x plus 1, a minus 2x, if I have this situation, if x less than 3, x bigger than 3. Okay, so to observe it, we graph it first. So when we graph it, use your t-table. So x is what? When it's less than 3, you plug in, become x plus 1, right? So we have 1, 2, 3. 3 becomes what? 4. Right? So that's 3, 4. X is 0 plus 1, x 0, y is what? 1. So when I graph, if x is less than 3, less than or equal to 3, so including this point, right? Then for this one, if x is bigger than 3, x is 3, then plug in y is what? 2. But it's bigger than 3, not equal to. When x is 4, y is what? 0. So you have this graph. What kind of graph we call this? Piecewise function, right? So take a look. We say if it's a limit, we want to find the limit of, so we want to find the limit of what? F of x equals 4. Oops, I shouldn't tell you that yet, right? So we approach to the right-hand side, and also we check from the left-hand side and right-hand side, right? So if from left-hand side means what? Less than 3, I will plug into here. For the first one, so it's 4. If from right-hand side, I approach from right-hand side, then I should plug in the second one. Then my value actually is what? 2. Are they the same? No, because your y is not bounded by one number. So we will say what? Limit x approach to 3 equals what? Doesn't exist, right? Because the limit, it means what? The y is bounded by when x approach to that number, and you have what? Because you have 2 values for y. Then y is not bounded by, so it doesn't exist. So sometimes the limit doesn't exist. You may still wonder why we are learning all this. So it is the basic concept of the calculus. So we just have to go through it for section 2.1 and 2.2. And once we get over it, then when we apply it and use it, that will be much easier. Okay, so let's see. Next one, finding special cases. So one situation is what? Limit doesn't exist. Okay? Another one is find the limits, okay, involving special situation to the infinity. So one is limits, another one is the infinity. Then that's very abstract concepts for you. Okay? So let's take a look. What are we talking about? Another thing, remember, we did is the asymptotes. Something relate to infinity. Okay? Maybe we see some examples, then you'll probably connect it better. So if I have a function like this, oh yeah, for this piecewise things, is that the function? What do? You use a vertical line test. Yes, it is the function. It is a function, right? So we are going to check this out for infinity things. Okay? So we did this. This one is what? Look at the example on your rational function. We mentioned quickly earlier on your page 10. Okay? Also, we can use the calculator to figure out. Okay? So, what do we have on the page 10? You use the calculator, so you graph it. Do you think x can approach 2? So 1 and 2. You know, because denominator cannot be 0, so when x is 2, it's almost impossible, right? So it doesn't exist. So that's your x limitation. Okay? What happened? We use calculator, you will find out the graph will look like this. This is your y equals what? 3. This is your x equals 2. When you graph it, you get this. Okay, use the website or use your calculator, and let me see, x is 0, 0, -2. Okay, that would be x is 0, -2, 0, and -1. Okay, so your graph will somewhere look like this, right? Use your calculator to see it. So we say if that's x2, right? So we say when from the left, so from the left, right? From left, we do what? For this one, f of x, we are talking about limit 3x plus 2, x minus 2. We do it from the left-hand side. When you do it from the left-hand side, okay, like this, x is approach to -2 from left-hand side. So x is going closer and closer and closer. Then what happened to your y? Your y value is going down. So from left, then your limitation actually is no limitation, become negative infinity. Okay? If from right, what do we have? Limit x to the right, from the right hand side. So according to the graph, what happened to your y value? Y value will keep going, becomes what? Positive infinity. So they are, besides infinity, they are not bounded by a value or one value. So we say what? The limit of x to the right hand, from the right hand side and left hand side, we say what? It doesn't exist. When the y value is infinity, positive or negative, then y is not bounded by, so it's not doesn't exist, right? And so when this situation x approach, so we say what? You have a vertical asymptote bounded, but for x, for the graph, then you cannot cross this line, so we have what? Vertical asymptote from the graph, right? It's what? X equals 2. Okay? Another thing we talk about is strange for you. It is strange for you. However, that's just go over it. So, if I have this thing, all right, so as what? If x approach to infinity, so x is bigger, very big, right? You can see when x is very big, but it still limits the y value can go up very big, but cannot go down below the line. So the limited by that thing. So what do we have? Right? We have a limit. We say limit this one to the infinity is what? 3. In this class, we don't expect you to actually do this. In pre-calculus class, then you have to find out how to do that. But we just do it by observation. So when we have this situation, right? So when you from right hand side is this way, right? From the when x approach to positive infinity, you have this situation. When the approach from negative, when it goes to negative infinity, the value still what? 3, right? And So we have, because we have this one with a horizontal asymptote of what? Y equal to 3. So at the same time, with, asymptotes are related to something bounded by and limited by with the concepts of the limits. Okay, so abstract concepts in this class, the most abstract concepts for you are the limits and infinity. Okay, so we don't test you a whole lot on those, and just get a basic idea in case you go more advanced study. It might be handy. So let's look, finding the limit of function of 2 variables. Okay, so if I have this one, we say h approach to 0, x squared plus x h plus. We need to use this in later on for your calculus part, right? So take a look. How many variables I have? 2, x and h. But I only focus on what? Only h. So you take a look. Can I plug into the h into there? Oh yes. So I plug in. Okay, I plug in 0, 0 here. So the result is what? So I plug in, right? Because I can plug in, most likely you can find the limit just for now. And so that will be your answer for this. This is the page 22, special cases for the limits. So usually when you can plug in, you do that. When you cannot, we need to do something else. Let's talk about continuity. We are on page 23. Okay, so this section 2.1, we are talking about what? Limits and continuity. Actually, they are related. Okay, so another abstract concept for you. And let's talk about what is a continuity. What do you think? What does continuity mean? Right? It means continuous, something. So formally we say, we talk about function of x, f of x, right? So we say this graph, talk about graph, see whether or not it's continuous. So the graph is continuous at a point, certain point we are talking about. One point at a time. Means what? Means the graph, okay, at C, at this point, at this time, is what? Continuous. What do we mean by continuous? That means continue, right? There will be what? No holes, right? No holes or no jump. That's just the concept. So we look at the graphs, take a look. 3 graphs. Is this a function? Right? Is this a function? Yes. Is this a function? Yes. All of them are function. So for this one, we talk about for this, at this point of time, see the graph will be continue, right? We continue. So then for this one, at the C, it jumped and come back and go again. Then for this graph, then this go here, oops, jump, but not the two solid point, otherwise it will not be function. So here, then jump and continue. So the first one is continuous, so then those are what? No, right? Obviously. So, and let's take a look the next one, how we are going to connect the continuity and the limits, because somewhat they are related. Okay, so we identify them first, then take a look more. So let's see. For here, we have three things like this. First one, that's your C, that's your FC. So you have graph like this, that's hollow point, right? So for the second one, that's our C. We just use the simple straight line. So I'm going to do that in here, here, and here, right? Let's see what does that mean. That's my f of C. That's my y value at this point C. Okay? If I have this one, C, then I have this one, then jump and come back here, right? Let's identify them first. Are they, say, okay, first we have to decide, is this a function, right? If it's not a function, we may not want to talk about it. So another one is that continuous at this point C, right? Then we say, do we have a limit at C at the point of time? So let's take a look. So first we have to decide if it's a function. How do we decide if it's function? Vertical line test. This one at the C you have no value, right? But for the function, when x is 1, 2, 3, 4 all the way, y is only one value. Yes. Is this a function? Vertical line test. This means what? Before this time, you go up. At this time, you have fixed number. And after this time, you go up. Vertical line test. This one is going up. Oh, jump at this point. Oh, come back to the normal pattern. It's a function. Is this one continuous? What do you think? Oh, break down at this point. So, no. Is this one continuous? Of course, the graph is not continuous, right? Is this continuous? No. Okay, look at the limit. What does limit mean? Limit means what? You approach before the time and after the time. Then at that time, the y value is that bounded by something. Yes, because you approach to same point from left and right. Not continuous, but y is bounded by, right? From both ends. And how about this one? Not continuous, but is the value bounded by. So when you approach to left, you approach to this value. When you approach to right, you approach to this value. So do we have same for the y value? Y value is this one, but when you approach to from either side, is that bounded by? You bound from left hand side, bounded by this point. From right hand side, you bounded by top point, right? So this one is not, doesn't exist for the limit. Then for this one, at this time, C value, Y value is this at C. But is the Y value bounded by from left hand side and right hand side? So from left hand side, you approach to this number. From right hand side, you approach to this number. So it is. Okay, it has limits but it's not a value at that time. But according to the definition, the concept of limit, it is bounded by a certain value, so it is the limit at point C. Let's do some more practice on the limits and continuity. Okay, so look the graph. What are we talking about? We are talking about x values map to y. So is this a function? Look the graph by vertical line test. Yes, it is a function. So often you get confused what we supposed to look. We are looking the function. What is a function? A set of paired order, right? A set of ordered pairs. So that means all the x, y on the lines, that's what we are talking about. So let's take a look the limits again. Then for the first one, limit when x approach to -3. So we decide whether or not it has a limit, right? So when x is at -3, do we have a limit? That means when the x approach to -3, either from left side or right side, and the value of the y is bounded by a number, just one value or not, right? By looking at that, yes. So the y value is approach to 0 either from at the time x is -3 from right hand side or from the left hand side. Let's take a look if x approach to -1. So you look at the x from -1. What's your y value? From left hand side, you approach to y value as 2, right? And from right hand side, the value is -1. And at -1, its value actually is 1. Okay, but from left hand side and from right hand side, they are different. So is the y value bounded by one value? No, right? So it doesn't exist. Look at another one. How about at the point x is 0? X is 0, right? From the left hand side, its value is what? Infinity. Y value is infinity. From right hand side, y value is what? Approaching to -1. So it's not bounded by a one value, just one value, right? So it doesn't exist. Look at the next one, next point, approach to 2. X approach to 2, at this point, from left hand side, it approaches to what? Value of y is -1. And from right hand side, it approaches, right, to the value, same value. So the limit of the y is bounded by both from right hand side and the left hand side. It's bounded by the y value as -1. That means from right hand side you get this, from left hand side you get the same value. So we do have the limit at the point of time x is 2. Okay? Let's take a look at the continuity. So, we are talking about the graph, the purple one, right? That's our f of x. So, which is derived from x, right? X to y. So, at which point it's not continuous. So you just look at the graph, oops, it breaks before you continue. So it's not continuous. So at the point x is what? -1 at this point, y value is not continuous, right? So because what? It jumped. And then you continue to go, oops, at this point x is 0. From left hand side it goes up, up, then drop back down, and continue from here. So it jumped again, so it's not continuous. Then after this point we continue. When we reach x is 2, right? Oops. Somehow it skipped that point, then continue on, right? So at the point 2, x is 2. Then we got a hole there. Then it stopped and jumped over, so it's not continuous. This is on page 23 and for the section 2.1.